Today we're going to talk about cubic and cube root functions and finding inverses. Y equals x cubed is the parent function for the cubic function family. This is the graph of y equals x cubed. 0, 0 is similar to the vertex, but it's the central point. Y equals a parentheses x minus h to the third power, plus k is similar to vertex form of the quadratic, except instead of being a 2 as an exponent, it's a 3. So h and k will tell you where your central point is, and it also tells you how the graph shifts. Left, right is h, up and down is k, and then a is what either stretches it or shrinks it vertically. For the parent, again, the vertex is 0, 0. The domain is negative infinity to infinity, or all real numbers, so the fancy R. And same thing for the range. It is a continuous function. So we're going to graph y equals 3x plus 5 cubed minus 7. So again, what I would do, like I do in most of these situations, is write the other equation directly below to establish all of the variables. Alright, so A is 3, H is negative 5, and K is negative 7. So the vertex or central point is negative 5, negative 7. So we can plot that point first. Alright. I would also build a table if I were you. So you have your x's, and then y again is equal to 3 times x plus 5 cubed minus 7. We only need 3 values, really. Putting your vertex in the middle. So negative 5, negative 7. And then find one x value less than it. So I would use, keep it simple, negative 4. Sorry, that's not less. Negative 6 is less than negative 5. And then you need one larger or greater than it, so negative 4. And then plug them into the equation to find their y values. Alright, to save you some time, if you have a graphing calculator, you're welcome to use it. Otherwise, you got to do the steps by hand. So I know negative 6 plus 5 is going to give me a negative 1. Negative 1 to the third power is negative 1. Negative 1 times positive 3 is negative 3. Negative 3 minus 7 is going to give me negative 10. Negative 4 plus 5 is 1. 1 cubed is still 1. 1 times 3 is 3. 3 minus 7 is negative 4. Again, you can confirm it with a calculator. If you don't trust me, let's put it into the calculator. So 3 parentheses negative 6 plus 5 to the third power minus 7. So negative 10, and then second enter, and change change this to a -4. -4. All right. So I need to plot -6, -10. So that's right here. And then -4, -4, which is right here. And do your very best to make it curve like an S. Again, this is where the curve starts at the vertex. All right, label your points, please. And that's a good graph. So again, I identified my H and my K so that I can find my vertex. Put it in the middle of your table. Find one X value larger, one X value smaller. I would always use just one more. Keep it simple, please. Trust me. And then plot those 3 points and make it the best S curve you can. So before I go on, let's talk about transformations just in case. So I told you that H will move it left and right. Since H is -5, that means it's going to move to the left 5 units from the parent. Remember, the parent started at the origin. The parent started here. So it went to the left 5. K moves it up and down. So since K is -7, it went down 7 from the origin. And then the 3, that's a vertical stretch by 3. So again, it went left 5 units. It went down 7 units. And a vertical stretch by 3. Complete this graph on your own. Now we're going to talk about the cube root function. Y equals the cube root of x. So notice there's a little tiny 3 on the root sign. Make sure it's tiny, and then it's a cube root. If it's big and it's in front of the root, it's still a square root. So the little 3 has to be tiny and it has to be located in the V portion of the root. So just make FYI. And this again is the parent. So the parent also has a vertex or a central region where the curve will start. And it's much shorter than the previous, but it's still an S. The domain and the range again are all real numbers. You can write it in vertex form. A cube root x minus h plus k. H and k still have the same movement, and A, again, will either stretch it or shrink it vertically. So let's practice graphing a cube root. So let's write down the generic form of the equation. Y equals A cube root x minus h plus k. Make sure the plus k part is not under the root sign. So that means A is -5/2. H is 6. And K is -9. Now notice H wasn't under the, wasn't in parentheses, but again, that symbol is still a liar. So make sure you bring it down and change the sign. So that means our vertex or our centralized point is 6, -9. So we can graph that point first. I'm kind of running out of space. So I might want to go by 2s or change my axis. So I will just change my axis. And I'll move it up. There we go. So this is -1, -2. All right, so 3, 4, 5, 6, 2, 3, 4, 5, 6, 7, 8, 9 is right here. So there's our vertex. Again, let's build a table. All we need is 3 values. Put the vertex in the middle. So 6, -9. 1 less than 6 is 5. 1 more is 7. So let's find the y values. And make sure the -9 is not included under the root. I accidentally did that at the top of my table. And I'm going to set up the second one as well and then grab the calculator. All right, so -5/2. For cube root, you can go to Alg2, I believe. Function. And it's number 6. Oh God, no. Hold on. All right, let's go to math. Yeah, that's the old school way. I could have used that. I was just using it incorrectly. So don't do that. So second quit. Take me back. So alpha y equals, oh, I want the negative back. Negative 5/2. So cube root is under math. It's option 4. All right. And we're going to type 5 minus 6 under the house. Leave the house, then the -9 for the first one. And it gives me -13/2 as a decimal, since we are graphing, -6.5. And then I'm going to copy that problem and just change it to a 7. And then change it to a decimal. -11.5. So -6.5 was the first one, and then -11.5. So another reason it was good to shift it up. So 5 and -6.5. So I'm at -9. So 8, 7. This is 6. So 6.5 is here. And I need to be at 5. So right here. All right. And then I need to go down 2.5 and over 1. So about here for the other. And make it your best S curve possible. And label. So 5 and negative 6.5, 6, negative 9, 7, and negative 11.5. And there's our graph. So let's talk about the transformation. So H is 6, so that went right 6 units. 8K is negative 9, so it went down 9 units. We have a negative value for A, so when it's negative, that reflects the um, y-axis, sorry, the x-axis. And then it was a vertical stretch. Oh, by 5/2, which is about 2.5. So that negative made it reflect the x-axis. And then the 5/2 was the vertical stretch. So 4 things occurred on this one. So work on this one on your own in the same manner. Now the cube function and the cube root function are inverses. If I graph them at the same time, they both reflect over the line y equals x. And by definition of an inverse, that's what happens. So now we're going to work on finding the inverses. The directions are replace f of x with y if it exists, switch x and y because the definition of inverse means to switch x and y, and then solve and get y by itself. So for the first one, I don't have f of x, which is great, but I need to switch x and y. All right, and then get y by itself. First thing I'm going to do is add 3 to both sides. So I would have x plus 3 is equal to the cube root of y plus 2. Now to get to y, and I have to remove the cube root. To remove the cube root, I have to cube, and I have to cube both sides. So that way on the left I would have x plus 3 in parentheses now with a power of 3. And then on the right I just have y plus 2. I no longer have the root if I apply the power of 3, which is the inverse. And now to get y by itself, the last step is to subtract 2 on both sides. So it would be x plus 3 in parentheses cubed minus 2 equals y. So in function notation, it would be f inverse of x is equal to x plus 3 cubed minus 2. Okay, so remember f to the negative 1, that's f inverse. Don't forget that. So on the right hand side, I would do a similar idea. First things first, switch x and y. So x equals y plus 3 cubed minus 2. Then I would add 2 to both sides. So x plus 2 equals y plus 3 to the power of 3. Now to get rid of the parentheses and the power of 3, I need to use the cube root on both sides. So on the left I have the cube root of x plus 2 On the right, I just have y plus 3. And now I will subtract 3 from both sides to get my final answer. So cube root x plus 2, and then minus 3 not included under the root is equal to y. So the inverse f of x, f inverse of x is equal to cube root x plus 2 minus 3. So I took the same equation and I basically found the inverse using the same process, but again I showed you both ways, going from a root to a cube and from a cube to a root. So there's kind of a shortcut again, but you have to be careful doing that shortcut. And we talked about it when we did the quadratics. So the shortcut is similar. In goes out, out, why is it moving? Sorry. Out goes in, change symbol and signs. So what I'm saying in that fact, if I was to use that pattern, this problem started with a root, right? So the new symbol would be a cube. So the inverse, let me rewrite it. I don't want to do that. Okay, let me just rewrite it. So y equals cube root x plus 2 minus 3. So according to the pattern, it would be y equals parentheses power of 3. And we know we have x in there, right? So if it starts with a root, it's going to finish with parentheses and a power. If it starts with parentheses and a power, it'll finish with a root. So here's where I use in, out, out, in. So positive 2 is in the symbol. Move it out of the symbol and change the sign. So minus 2. The minus 3 is out of the symbol. The minus 3 goes into the symbol and change the sign. So plus 3. So that's how the pattern works. But you have to be very careful because if you have A, the pattern doesn't necessarily work that way. So on the problem where you're trying it on your own, the pattern's not really going to work that way. So show your steps, try that problem on your own. This concludes your notes for this lesson. Good luck.